Hi, I'm Uncle Said, and I'm part of the field engineering team here at Wallaroo. Today, we're going to look at how Wallaroo simplifies the process of configuring and deploying AI models to leverage IBM's Power10 architecture. IBM Power10 offers high-performance, scalable processing for data-intensive workloads, whether in the cloud, on-prem, or at the edge, all without compromising on AI governance and operational efficiency. In this demo, we'll walk through configuring two models, an open-source large language model and a computer vision model, both optimized to run on IBM's Power10 architecture. We'll also touch on how Wallaroo helps us extend our models to leverage the Power10 architecture at the edge. Let's dive in. To start off, we'll import Wallaroo's pip installable SDK. Once imported, we'll connect to our Wallaroo client and workspace. With that in place, we're ready to use Wallaroo's tried and true three-step workflow with one small tweak to configure and deploy our open source LLM to work with IBM's Power10 architecture. We start by uploading the model. As usual, we're passing the model name, file path, model schemas, and framework type. Wallaroo supports a wide range of ML frameworks, but for this example, we're using Wallaroo's custom framework. Allowing us to create models with more complex bespoke workflows, Wallaroo's custom framework is perfect for our custom RAG implementation using a quantized version of Llama 3. Along with the usual parameters, we'll also set the arc parameter to Power10. This ensures that the uploaded model is optimized to run on IBM's Power10 architecture. From here, Wallaroo will take care of the rest. Thanks to Wallaroo's flexible framework, Wallaroo abstracts away the complexities, allowing engineers to leverage IBM's Power10 architecture by setting just one extra parameter. Once the model is uploaded, the other two steps of our three-step workflow remain the same. In the next step, we'll configure our deployment hardware. In this instance, because our Llama is quantized, its resources efficient enough to run on CPUs alone. So we'll allocate 8 CPUs and 10 gigabytes to the model. Finally, we'll build and deploy our pipeline. And in just 2 minutes, our LLM is deployed and running in the cloud, ready for testing. We'll validate the pipeline to make sure it works as expected. Once we're confident everything is in order, the pipeline is ready to be used in production. From here, we can easily retrieve the URL endpoint and start making API calls. And that's how, by simply adding one extra parameter, we've adapted Wallaroo's three-step workflow to optimize and deploy our LLM on IBM's Power10 architecture. Now that our pipeline is live, let's head over to the Wallaroo Operations Center. Here, we can see our newly deployed pipeline along with others in our system. Let's click into the pipeline we just deployed. In the details, we can see previous versions of this pipeline, see the current status, and even view the engine configurations. If we take a closer look at the engine configurations, we'll see that the model is indeed configured to use IBM's Power10 architecture, just as we set it up earlier. Switching over to a pipeline that's been running a bit longer, we can see, just as we'd expect, our models optimized for Power10 are fully leveraging Wallaroo's powerful feature set. This includes centralized logging, observability, and Wallaroo's automated drift detection system, better known as assays, allowing us to observe and ensure our pipeline's performance in production. Moving back to our notebook, we'll see how we can extend our workflow to allow our models to work on the edge when configured with IBM's Power10 architecture. In this example, we'll look at an object detection model, which would be used in a retail space. To start, we'll upload the model as we did before, passing the model name, file path, and framework type. We'll also set the arc parameter to Power10, ensuring our model is configured to work with IBM's Power10 architecture. Once uploaded, we'll configure our deployment hardware. This time, we'll keep the specs lean, just one CPU and 1 gigabyte of memory for this smaller model. Finally, we'll build and deploy our pipeline. Once deployed, we can test it out and retrieve the URL endpoint. Now, to extend this to the edge, we'll follow our usual edge workflow, which consists of 2 extra lines of code. In the first, we publish our pipeline. This turns it into a containerized, standalone process that can run on edge devices with all its dependencies included. Once published, we'll add an edge bundle. This allows the logs from our edge device to return back and be consolidated in the operations center. With the edge bundle added, we can see the details of our edge-ready pipeline, including its container and artifact information. Finally, we'll find our Docker run command, which we can take to the edge to deploy the model on-site. Now, because we've had this pipeline running for a while, let's jump back to the Operations Center to check it out. In the Insights tab, we can see exactly what we'd expect. The logs from our edge devices are fully consolidated and available here in a single centralized view. This gives us visibility into how our edge locations are performing in production, ensuring everything is running smoothly. And there you have it. Using just one extra parameter, we were able to adapt Wallaroo's three-step workflow to easily deploy and extend our AI models to take full advantage of IBM's Power10 architecture, whether in the cloud, on-prem, or at the edge.